This is a fairly challenging middle school word problem. I will solve this problem algebraically. So let's go ahead and read the question. There were pelicans, herons, and flamingos on the beach. For every pelican, there were 2 herons and 3 flamingos. After some of the herons flew away, for every remaining heron, there were 2 pelicans. After some of the flamingos flew away, for every remaining flamingo, there were 3 pelicans. If the difference between the number of herons that flew away and the number of flamingos that flew away was 21, how many pelicans were there? So go ahead, try to solve this problem any way you can. However, if you want to watch the solution video, you can go ahead and watch it too if you want, but I will solve the problem algebraically. But I would encourage you to try the problem on your own. Whenever we are solving an algebraic problem, it's very important to define our variables very clearly. And before we can define our variables, we have to absolutely, genuinely understand the problem. There is no guesswork. You have to understand the problem. You have to deal with the language issues. For instance, if there is an ambiguity, hopefully there aren't any, but if there are, you have to absolutely take a stand and say, this is how I'm interpreting it, and that's certainly consistent with the question. So you have to do some of those things. So you absolutely have to understand the question. If you read the question a couple of times, you're going to see that the number of pelicans is not changing. There are lots of herons, lots of flamingos, and some pelicans. The herons and flamingos are flying away. So what's going on? So I see originally there were, for every pelican there were 2 herons, and for every pelican there were 3 flamingos. Now this line tells me originally there were twice as many herons as pelicans and 3 times as many flamingos as pelicans. So that's one way to interpret that line. Another important line is this line. After some of the herons flew away, for every remaining heron there were 2 pelicans. So originally there were twice as many herons as pelicans, but after some of the herons flew away, there were twice as many pelicans as herons. A very key fact. What about this line? After some of the flamingos flew away, for every remaining flamingo there were 3 pelicans. So originally there were 3 times as many flamingos, but after some of the flamingos flew away, the number of pelicans was 3 times the number of remaining flamingos. So what I'm going to do, I can use fractions, no problem, but I'll try to avoid using fractions in my variables. So a way to deal with it is I'm going to choose 6x to be the original number of pelicans, and we're going to talk about why that's a good choice. So I'm going to say the original number of pelicans, let's say, was 6x. Okay. So this is the original scenario: number of pelicans, number of herons, number of flamingos, and the new case would be the new number of pelicans, the new number of herons, the new number of flamingos. Now, originally, if there were 6x pelicans, 6 is a product of 2 and 3. We have, many things are being multiplied by 2 or divided by 2 or multiplied by 3 or divided by 3. That's why 6x is a good choice. Now, if you go back to this statement, originally for every pelican there were 2 herons and 3 flamingos. So this has to be, the number of herons has to be 2 times 6x. That's going to be 12x originally. And the number of flamingos, the original number of flamingos has to be 3 times 6x, or 18x. Okay. Now, After some of the herons, let's do this in green. After some of the herons flew away, for every remaining heron, there were 2 pelicans. What does that line mean? The line that has been underlined with green marker, it simply means after some of the herons flew away, there were twice as many pelicans as herons. That's another way to read that line. Now, if you read the whole question, you're going to see the number of pelicans is not changing at all. So I'm going to write the new number of pelicans is still 6x. 6x. It hasn't changed. So what is after some of the herons flew away? If the number of pelicans was twice the number of herons, the number of herons has to be 3x. Now that follows, the green variable 3x follows from the line underlined with green marker. Again, read this sentence very carefully and absolutely convince yourself that that's a valid interpretation of this sentence. So we're going to try the next one. After some of the flamingos flew away, for every remaining flamingo, there were 3 pelicans. What does that line mean? That simply is telling us some of the flamingos flew away, and after some of the flamingos flew away, the number of pelicans was 3 times the number of flamingos that were left behind. That is another way of saying that after some of the flamingos flew away, the number of flamingos was 1/3 of the number of pelicans, and 1/3 of 6x is going to be 2x. All right. Now, these two numbers, 3x in green and 2x in blue, follow from the underlined sentences that are consistent with the colors. Now, you absolutely want to understand how these two variables are defined. Actually, you have to understand how all these 6 little blocks are filled in, how they're consistent with the question. Once you get it, the rest of the problem is pretty straightforward. This line, if the difference between the number of herons that flew away and the number of flamingos that flew away was 21, how many pelicans were there, is the line that we're going to be using to write our final equation that we will use to find the value of x. So first let's find the number of herons that flew away. This is the original number of herons. This is the new number of herons. Some of them flew away. So if you subtract 3x from 12x, you're going to get 9x. That has to be the number of herons that flew away. If this is the original number of flamingos and this is the new number of flamingos and some of the flamingos flew away, if you subtract 2x from 18x, you're going to get 16x. That's the number of flamingos that flew away. Now, the question says the difference between the number of flamingos that flew away and the number of herons that flew away is 21. Clearly, I can see that more flamingos flew away than herons. So I'm going to write my final equation as follows. I'm going to do it here. I'm going to conclude 16x minus 9x has to equal 21. And 16 minus 9 is 7x. That has to equal 21. Therefore, x has to equal 21 divided by 7, which is 3. Now the question wants us to find the original number of pelicans. If x is 3, the original number of pelicans has to be 3 times 6, or 18. That's my answer. There were 18 pelicans originally. 18 is my answer. I'm going to write 18 here.